Okay, welcome back to Morals Math Corner. We are here today going to talk about radian measures. Now, radians are pretty much just a fancy way of writing a degree. In fact, 1 radian is an angle, okay, with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle. Okay, let's explain that in English. We know that when we're talking about a unit circle, gentlemen, that the radii of that unit circle is 1, right? So all of these radii are 1. That's what defines a unit circle. It's a circle where the radii is equal to 1. Now, how do you know that they're talking about a radian and not a degree? First of all, a degree will have a symbol for degree. Radians will not, okay? Radians, you can have, for example, like 2.7, and you just leave it like that. You don't put a degree symbol. That is going to be interpreted as a radian. The radians have no symbols that attach to it or any units that label it to be a radian. That's why it's very important to label your degrees or feet or meters. Label your units because radians have no labels. I wish it was, an R, but it's not. I'm sorry. Another popular way to describe radians, and we're going to go through all of this today, is in pi format, pi over 3. Okay, those would be radians. That's a degree because it has a degree symbol. So that's one difference. Secondly, let's try to investigate this definition a little bit. It says here that it's a radian when the angle intercepts an arc that is equal to the radius of the circle. So when I have a radian, what's happening is I have not a degree, but an angle theta that intercepts an arc that is equal to 1. That's what a radian is. When you're talking about radians, it's an angle measure, okay, who intercepts an arc that is equal to the radius of the circle. In our particular case, since it's a unit circle, that arc distance, arc length is equal to 1. So that's what a radian is. A degree doesn't have all of those parameters, but a radian does. Okay? So now, how do we convert from radians to degrees and degrees to radians? Well, luckily, we already investigated this. Remember, I took you guys a little bit ahead last chapter. But we're going to revisit it, okay? When we're converting degrees to radians and radians to degrees, number 1, to convert a degree to a radian, you simply multiply by pi over 180. Literally. Okay? It's exactly what you do. So, for example, if I have 50 degrees, I want to turn it to radians, multiply that bad boy by pi over 180. If you can reduce, please, you must reduce it and leave it in pi format. If you can reduce the conversion, you reduce the fraction and leave it in pi format. So in this case, I can get rid of a 10, and this is going to equal 5 pi over 18. Mr. Morrow, is it wrong if I go ahead and go 5 times pi divided by 18? No, it is not. If you did that, or if you are an SAT or an ACT or one of my tests, or you had a multiple choice for whatever reason, and you're trying to convert this radian, and they give you 5 pi divided by 18, and they give you the actual 0.87266. These are both accurate, but I'm going to ask you, please, to stay consistent with the general feeling of trigonometry. If you can reduce it, I am requiring you to reduce it and leave it in pi format. You had a question? Yes, sir. Yes, great question, son. The question was, do we use the pi key or 3.14? In Trig, we're talking about exactness, okay? When we're talking about Trig, we're talking about building bridges, finding real distances, railroads, you know? You ever think about how they built a railroad? How do they know how much metal to use? How do they know how much wood to use? How do they know how many, they're not called nails, but, you know, they're not screws either, but the big bolts that they stake into there, you know, they're not nails, but they're really big nails. How many of those to use? This wasn't just a gamble. They didn't just say, well, let's say 1,000. Hey, let's see if it works. No, they actually had calculations. So since we're dealing with trigonometry and we're dealing with exactness, we need to use the pi button from now on. Easy. We're not going to use 3.14. So if you have a calculator that does not have the pi button, you need to get a scientific, please. So that's how we go from degrees to radians. How do we go from radians to degrees? Well, same thing. Let's say that I give you a radian in the following format. 8 pi over 5. Okay? I want to turn this into a degree. Well, I'm going to multiply by 180 over pi. Now the beauty here, since the pi's go bye-bye, can I use my calculator now? Absolutely, because we're talking about numbers. So 8 times 180 divided by 5, you're going to have 288 degrees. Please, please be sure to label degrees. Okay, so let's continue now. All right, let's try some of these. Remember, I have here in blue, if you can reduce the radian angle measure, leave it in pi form. If not, use the calculator. Very simple. So in this particular case, you're going to multiply by pi over 180, and that, very good. It's going to be pi over 4. Done. You don't label it with an R, you don't label it with anything. It is a radian measure. Now in this particular case, I am not going to be able to reduce. So in this particular case, you have full reign to be able to go 249.8 times pi divided by 180, and that's going to equal 4.359. So in other words, about 4.36. I will, of course, tell you whether to round to the hundreds or the thousands, etc., etc. Okay? Next. I apologize for that annoying noise. Next, convert each radian measure to degree. Now we're going to degrees. So I'm going to multiply by 180 over pi. Remember, if I can reduce it, reduce it. So those go that way. Well, in this case, we don't have to reduce. We can just multiply. And that's going to be 360, and yep, 405 degrees. In this particular case, I have this radian here. Now, don't stress out. This is just the radian in decimal form. How do you know it's a radian, Mr. Morrow? It doesn't have a degree symbol. So 4.25 times 180 equals, divided by pi, equals 243.5 degrees, or 51 degrees if I went to the hundredths. Yes, sir. The pi doesn't cancel anything, son. I went 425 times 180, and I divided by pi. I hit pi on my pi key on my calculator. Thank you, son. Next, now, let's put this all together. All right, we know how to find already function values when they give you a degree measure. Same difference when they give you a radian measure. Now, this guy here, Mr. Morrow, never liked working with radians. I don't know why. I just never did. Some of you may love it, and if you do, God bless you. I never did. So what I always did, guys, was I first converted this always to a degree measure. That way I don't have to mess with my calculator either. I cancel out my pi's. That goes 6. So this is the tangent of 120 degrees. Now, hopefully we all remember how to do this. This is a positive angle, so it's going counterclockwise 90 plus 30. So what's my reference angle here, gentlemen? 60. Very good. What's the tangent of 60 equal to? Tangent of 60 is equal to radical 3, but it's in the second quadrant. All students take calculus, so it's negative radical 3, and that's your answer. Does that make sense, gentlemen? Okay. And I think that we are... No, one more thing. Let me just go back to this unit circle. I know that you guys have this already on a sheet that I gave you. But let's investigate this a little bit more. Hopefully, we're starting to get the rhythm here. Let me show you how powerful the unit circle is. Remember the quadrantal angles. That's why you have 1, 0, and 0, 1, negative 1, 0, and 0, negative 1. I just finished telling you that I never really liked working with radians, but there are some radian measures that you must memorize. Must. You got to memorize that 2 pi is 360. You got to. You got to memorize that pi over 2 equals 90. You just have to. You got to memorize that pi equals 180. And you got to memorize that 270 equals 3 pi over 2. You got to memorize that. It's just no choice, okay? Also, another thing. This is my x, and this is my y, and they both lie on the unit circle. So when a point lies on the unit circle, what does my x equal also? That's the cosine value. What does my y equal also? That's the sine value. Remember also, gentlemen, that if you learn this quadrant right here, you've learned all 4 of the quadrants based on the 30, 45, and 60 reference angles, and based on the all students take calculus. Again, whenever you have a reference angle, whether they give it to you in radian form or degree form, the first thing you do is find the reference angle. That means that if you have it in radians, you may have to change it to degrees and find the reference angle. Once you find the reference angle, if it's a 30, 45, or 60 reference angle, you are not allowed to use the calculator. Any other, yes, so you have to memorize it. But any other one, use the calculator freely. Okay? Thank you very much. Have a great day. God bless you all. Be good. Stay classy, people. Bye-bye.